An NEMA 4 enclosure is indeed permitted for a junction box, often referred to as a J-box, situated in a Class 1 Division 2 location, given the crucial condition that no sparking devices are present within the enclosure. To understand why, let's delve into the specifics of NEMA 4 enclosures in Class 1 Division 2 locations. A NEMA 4 enclosure is designed and constructed to provide a significant degree of protection against a range of environmental factors. Firstly, it offers protection against wind-blown dust, ensuring that dust particles do not infiltrate the enclosure and potentially compromise the internal components. Secondly, it is designed to withstand rain, sleet, and splashing water, preventing water ingress that could lead to corrosion or electrical faults. Thirdly, NEMA 4 enclosures provide a level of corrosion resistance, crucial for maintaining the integrity of the enclosure in harsh environments. Finally, these enclosures are designed to prevent the ingress of oil, dust, and dirt, further safeguarding the internal components from contamination and potential damage. Now let's consider the characteristics of a Class 1 Division 2 location. According to the established standards, a Class 1 Division 2 location is an area where flammable gases or vapors may be present in the air, but under normal operating conditions, these flammable materials are not present in sufficient quantities to produce an ignitable mixture. This means that the risk of explosion or fire is significantly lower compared to a Class 1 Division 1 location, where flammable materials are routinely present. The suitability of a NEMA 4 enclosure in this scenario hinges on the absence of sparking devices within the junction box. Sparking devices can generate arcs or sparks capable of igniting flammable gases or vapors, even in small concentrations. Since the condition specifies that no sparking devices are present, the primary concern shifts to preventing the ingress of external elements that could potentially contribute to a hazardous condition or damage the electrical connections within the J-box. Given that the NEMA 4 enclosure provides protection against wind-blown dust, rain, and corrosion, it effectively addresses these concerns. The enclosure prevents dust and moisture from entering the J-box, minimizing the risk of short circuits or corrosion of electrical connections. The corrosion resistance of the enclosure itself ensures its structural integrity in potentially corrosive environments. Therefore, in a Class 1 Division 2 location where no sparking devices are present, a NEMA 4 enclosure provides an adequate level of protection for a junction box. It's important to note that while a NEMA 4 enclosure is permitted, it is crucial to verify that it meets all other applicable requirements of the National Electrical Code (NEC) and any relevant local regulations. These requirements may include proper grounding, bonding, and the use of appropriate wiring methods. Furthermore, regular inspections should be conducted to ensure the continued integrity of the enclosure and the absence of any conditions that could compromise its safety. To summarize, the permissibility of a NEMA 4 enclosure for a J-box in a Class 1 Division 2 location, where no sparking devices are present, is based on the enclosure's ability to provide adequate protection against environmental factors such as dust, rain, and corrosion, thereby minimizing the risk of electrical hazards. However, strict adherence to the NEC and local regulations, along with regular inspections, are essential to ensure ongoing safety and compliance. In addition to the general guidelines already outlined, it is crucial to consider specific aspects of the installation and application of NEMA 4 enclosures in Class 1 Division 2 locations. These considerations are important to ensure the safety and reliability of the electrical system. Firstly, proper installation is paramount. The enclosure must be installed according to the manufacturer's instructions and the NEC requirements. This includes ensuring that all seals and gaskets are properly seated to maintain the enclosure's NEMA 4 rating. Any gaps or openings can compromise the enclosure's ability to protect against dust, rain, and corrosion. Secondly, conduit and fittings must be appropriate for the location. The conduit and fittings used to connect to the NEMA 4 enclosure must also be rated for the environment. This typically means using rigid metal conduit or liquid-tight flexible metal conduit with appropriate fittings. The fittings must be properly sealed to prevent the ingress of moisture or dust into the enclosure through the conduit system. Thirdly, grounding and bonding are critical for safety. Proper grounding and bonding are essential to minimize the risk of electrical shock and to provide a path for fault current to flow back to the source. The grounding and bonding connections must be made in accordance with the NEC requirements, using appropriate grounding conductors and bonding jumpers. Fourthly, regular inspections and maintenance are essential. NEMA 4 enclosures should be inspected regularly to ensure that they are in good condition and that all seals and gaskets are intact. Any damage to the enclosure, such as cracks or corrosion, should be repaired promptly. The enclosure should also be cleaned periodically to remove any accumulated dust or dirt. Fifthly, documentation and labeling are important for traceability and safety. The enclosure should be clearly labeled to indicate its NEMA rating and the hazardous location for which it is approved. The electrical drawings and documentation should also clearly identify the location of the enclosure and its intended use. In addition to these practical considerations, it is also important to understand the relevant sections of the NEC that apply to NEMA 4 enclosures in Class 1 Division 2 locations. Article 500.1 defines and classifies hazardous locations. It specifies the criteria for determining whether a location is Class 1, Division 2, and it outlines the general requirements for electrical equipment installed in these locations. Article 501.1 covers specific requirements for Class 1 locations. It provides detailed guidance on the types of wiring methods, equipment, and enclosures that are permitted in Class 1, Division 2 locations. It also addresses issues such as bonding, sealing, and grounding. Article 314.1 covers the installation and use of junction boxes, pull boxes, and handhole enclosures. It specifies the requirements for the size, construction, and installation of these enclosures, including NEMA 4 enclosures. It is essential to consult these articles of the NEC to ensure that the installation of the NEMA 4 enclosure complies with all applicable requirements. It is also recommended to consult with a qualified electrical engineer or inspector to ensure that the installation is safe and compliant. Furthermore, it is beneficial to consider the selection of appropriate NEMA 4 enclosures for specific applications in Class 1 Division 2 locations. Various factors influence the selection process, ensuring optimal performance and safety. Firstly, material compatibility is crucial. The material of the enclosure should be compatible with the chemicals and environmental conditions present in the Class 1 Division 2 location. For example, if the location is exposed to corrosive chemicals, a stainless steel or fiberglass enclosure may be more suitable than a carbon steel enclosure. Secondly, size and capacity are important considerations. The enclosure should be sized appropriately to accommodate the electrical components and wiring that will be installed inside. Sufficient space should be provided for easy access and maintenance. Thirdly, ingress protection is a primary requirement. The NEMA 4 rating should be verified to ensure that the enclosure provides adequate protection against dust, rain, and other environmental factors. The enclosure should be tested and certified by a recognized testing laboratory to meet the NEMA 4 standards. Fourthly, accessories and features can enhance functionality. Consider the need for accessories such as windows, hinges, latches, and mounting brackets. These features can improve the ease of use and maintenance of the enclosure. Fifthly, cost effectiveness is always a factor. While safety and performance are paramount, it is also important to consider the cost of the enclosure. Compare the features and benefits of different enclosures to determine the most cost-effective option for the specific application. In addition to the above considerations, it is vital to address the potential consequences of improper enclosure selection or installation. These consequences can range from minor inconveniences to serious safety hazards. Firstly, electrical faults can occur if the enclosure is not properly sealed or if it is damaged. Moisture or dust can enter the enclosure and cause short circuits, ground faults, or other electrical problems. Secondly, equipment failure can result from corrosion or contamination. Exposure to corrosive chemicals or dust can damage the electrical components inside the enclosure, leading to premature failure. Thirdly, explosion risk can arise if flammable gases or vapors enter the enclosure. If the enclosure is not properly sealed or if it is damaged, flammable gases or vapors can enter and accumulate inside. If a source of ignition is present, such as a spark or hot surface, an explosion can occur. Fourthly, safety hazards can endanger personnel. Electrical shocks or explosions can cause serious injuries or fatalities to personnel working in the area. It is therefore essential to take all necessary precautions to ensure the safe selection, installation, and maintenance of NEMA 4 enclosures in Class 1 Division 2 locations. In summary, the proper use of NEMA 4 enclosures in Class 1 Division 2 locations involves a comprehensive understanding of the applicable standards, regulations, and best practices. By following these guidelines and taking the necessary precautions, you can ensure the safe and reliable operation of electrical equipment in hazardous locations. Remember to consult with qualified professionals and to stay informed about the latest developments in electrical safety.